Division of Polynomials. There is nothing new here. And this is the next section, 3.3, Division of Polynomials. Here I'm only going to address when we divide a polynomial by one term, like let's say x squared is an example. One term, one product called monomial. And then we will look at the long division. I hear the music from here. Maybe you want to turn it off, please. Long division, like a polynomial divided by another polynomial. Okay. So I don't want to make these up. I'll show you, and you choose. On page 392, there is no example like this, but I want to show one example before you choose the long division. So let's take a look. Let's say 4x to the fourth minus 3x cubed plus 2x minus 3 divided by one term. You want x squared, you want x cubed. What degree do you want in the denominator?
Can you go back?
Say it again. Yes. X cubed. We want to divide by x cubed. Well, there is basically no way of simplifying because we cannot simplify terms. But what we can do is separate the entire fraction into how many fractions, depending on how many terms we have at the top. How many terms we have at the top? Good. So then 4x to the fourth over x cubed minus 3x cubed over x cubed plus 2x over x cubed and minus 3 over x cubed. And you could say this is not a division at all. Well, I will simplify each fraction by itself. And this is useful for other things. Okay, when I simplify 3 from the denominator with 3 from the numerator, I have 4x minus. I simplify 3 from the top with 3 from the denominator, and I have minus 3. Plus, I simplify 1x from the top with 1x in the denominator, and I get 2 over x squared. And the last one, there is nothing I can do. This is as much as I can take it. 2. Nothing else. Done. So this is characteristic for only one term, nothing else. This method cannot be used for anything else. Just dividing any polynomial by one term, by one monomial. Okay, so now the long division. How many of you remember long division? I'm sure you've seen it, right? You've seen it. Okay, very good. So let's take a look at an example. Let's start with 21. You can choose the next, please. On page 392, 4x cubed minus 3x squared plus 3x and minus 1, everything divided by x minus 1. Well, I have to ask myself two questions before I start. Here's my first question. Is this polynomial in descending order? Is this polynomial in descending order? If they are not, I have to rearrange them. But it happens that they are. What is the degree of the numerator? The degree of the numerator is? Very good. Now I'm asking myself the second question. Is there any missing term? And you can say, how will I know whether there is a missing term? Well, any polynomial degree 3 should have degree 3, degree 2, degree 1, not power, but degree 0. And it does. It has all 4 terms. So there is no missing term. So therefore, there is no need to leave any empty space. So 4x cubed minus 3x squared plus 3x minus 1 divided by x minus 1. My first question to myself is this. X, I'm going to write them on the side. X multiplied by what is 4x cubed? And I put this quantity here. The answer up here. What? What do I multiply x to get 4x cubed? That's it. Awesome. 4x squared. But now remember, we have to go back and distribute to both terms and change the sign before we write under like terms. So 4x squared times x is 4x cubed. Change the sign to the opposite one. 4x squared times negative 1 is negative 4x squared. Change the sign before you write under like terms. In case you're wondering, why is she changing the sign? It's because we need to subtract. When we subtract a positive number, it changes into negative. When we subtract a negative number, it changes into positive. Question so far? The first to go away, as expected. Perform the operations I see, and I have an x squared. Bring down the next in line. And now here's my next question. X was multiplied by what to get x squared? And at the top, I like to say to my students, we do not lie. In other words, we don't change the sign. We just write the correct sign. So x times what is x squared? And the sign is plus x. Very good. Now I have to go back and distribute x and write below like terms after I change the sign. So x times x is x squared. Now I change the sign. X times negative 1 is negative x. But I change the sign and I write positive x. These are gone. This is 4x. And the last step is I have to bring negative 1 down. Final question, because these two have the same degree. This must be the final question. X multiplied by what is 4x? And at the top, we are true. We're putting the correct sign. Indeed, plus 4. Now we go back and distribute the 4, change the sign, so negative 4x, very good. And then 4 times negative 1 is negative 4, but positive 4. Gone. What is the remainder that has to be boxed in? 3 indeed. So how do I write the answer? I have to write the quotient plus the remainder over the divisor. So the answer will be quotient. This is the quotient. This is the remainder. And this is the divisor. Can anyone give us the final answer so we can write it? Yes, 4x squared plus x plus 4. Do not forget the symbol. Plus in this case, plus 3 over x minus 1 indeed. So in other words, I'm telling you that 10 divided by 3 is 3 integers and 1/3. It's an example, a numerical example. How will I check this? I know you trust me. I hope. It's 3 plus 1/3, right? But how do I check? 3 times 3 plus 1 is 10. How do I check this? This times this plus 3 has to equal this. If it doesn't, this is wrong. Cross it out and start from scratch. Any questions? Do we remember this? Would you like another problem? Okay, very good. Would you like to choose or would you like me to choose? Say it again. Alex? I'll choose. Fine. Okay. Let's look at 28. On page 392. X to the 7th plus x to the 5th minus 10x cubed plus 12 divided by x plus 2. This Second example is not a friendly problem. Can anyone tell us why I say it's not friendly?
7 degree.
First of all, because it's degree 7, I completely agree. The second thing is because it has plenty of
Terms.
missing terms. If the degree is 7, the polynomial has to have 8 terms. If the degree is 3, the full polynomial should have 4 terms. But it only has 1, 2, 3, 4. So how many are missing? 4 terms. So let's start. And yes, they're both in descending order. So x to the 7th is there, but x to the 6th is not. Leave some space. X to the 5th is there, but x to the 4th is not. Leave some space. Negative 10x cubed is there. X squared is not. X is not. So at the end, plus 12. So 4 missing terms. 1, 2, 3, 4. So the first question is, yes?
The whole space in between.
So this is degree 7, degree 6 is missing. Degree 5, degree 4 is missing. Degree 3 is there, degree 2 is missing, and degree 1 is missing, and degree 0 is there. Perfect. So x times what is x to the 7th? X to the 6th. Good. So let's go back and distribute. X to the 6th times x. Yes, it's x to the 7th, but we write negative. X to the 6th times 2 is 2x to the 6th, but we have to write negative 2x to the 6th. And that's why we needed that space. Then we have negative 2x to the 6th. Bring down plus x to the 5th. Next in line, x multiplied by what is negative 2x to the 6th? Negative 2x to the 5th. Very good. Awesome. Do we all agree? Can we keep up? Slow me down if you need help, or if you need me to slow down.
Slow down, please.
Okay, that's all you need to say. X multiplied by what is negative 2x to the 6th? And we do not lie at the top. Right? We have it. Oh, we already have it. See, if you slow me down, I forget what I'm doing. So negative 2x to the 5th times x, we have to distribute now. Negative 2x to the 5th times x is negative 2x to the 6th. Okay, positive. Negative 2x to the 5th times 2 is negative 4x to the 5th. Positive 4x to the 5th. Gone. 5x to the 5th. Yes?
Hold on.
You may be right, I may be wrong. If you see something, please say something.
Wait, where did the 4 come from?
Okay? Let's do that. Negative 2x to the 5th times x is negative 2x to the 6th, positive 2x to the 6th. Negative 2x to the 5th times 2 is negative 4x to the 5th, positive 4x to the 5th. Everyone with me? Perfect. Good. So now the next question. X times what is 5x to the 5th? Positive 5x to the... Very good. Awesome. 5x to the 4th times x. 5x to the 5th minus 5x to the 5th. 5x to the 4th times 2. 10x to the 4th. Negative 10x to the 4th. There is nothing I can do. I cannot combine it with that. So this is gone. Negative 10x to the 4th. I bring down finally negative 10x to the 3rd. It seems like it's never going to end. X times what is negative 10x to the 4th? But I chose the problem, so I have to work through it. Negative 10x to the 3rd. Notice something very important. Degree 6, degree 5. You're not going backwards. Degree 4, degree 3. So how many terms do you still expect?
3.
Degree 2, degree 1, and degree 0. We expect 3 more terms in there. Okay, I know. No, you're not going to have to deal with this, but we picked the problem, so now I have to finish it. No, I'm not going to put something like this because it took us 5 minutes. So on a test, this will probably take 10 minutes. No, we don't have time for that. So negative 10x to the third times x. We're just enforcing the method, basically. So it's negative 10x to the fourth, but positive 10x to the fourth. Negative 10x to the third times 2 is negative 20x cubed, so positive 20x cubed. So then this is 10x cubed. X times what is 10x cubed now? See, it doesn't even fit in one page. So positive 10x squared, very good. 10x squared times x is 10x cubed, negative 10x cubed. 10x squared times 2 is 20x squared, but minus 20x squared. So negative 20x squared, and I still cannot bring that down yet. It's the negative, it's positive 10 times 2. There is also a 2, always a 2, yeah. I know. Okay, x times what is negative 20x squared? Negative 20x. There's one more after this. So negative 20x times x is negative 20x squared, so positive 20x squared. Negative 20x times 2 is negative 40x, so positive 40x. So these two are gone, so positive 40x and plus 12. And finally, positive what? No, just 40. Remember, we already had 20x. The last one cannot contain x. So this is negative 40x, and then 40 times 2 is 80 minus 80. So this is negative 68. Can anyone give us the final answer? So we had x to the 7th plus x to the 5th minus 10x cubed plus 12 divided by x plus 2. Can anyone give us the quotient? The quotient has 1, 2, 3, 4, 5, 6, 7 terms. So x to the 6th minus 2x to the 5th plus 5x to the 4th minus 10x cubed plus 10x squared minus 20x and plus 40 and minus 68 over x plus 2. It was a good practice.